So I've received in this PCB that I put together for a Lattice iCE40 FPGA, and this is specifically for the HX4K, and this is a QFN 144 pin package, or what they label as a TQ144. And this, again, was the largest package I could get as far as I/O pins without going to a BGA, which I'll experiment with on later PCBs. But I'm using this one as my first experimentation. This PCB was a pretty quick PCB. I did a lot of auto routing in it, and follow-up PCBs will all be manually routed, I think. At least the next two I've done for BGA have been manually routed. So if you see some routing stuff on here, don't be too worried about that. The future version of this will get cleaned up. So I bring power in. I have 3 LDO regulators, one that brings it down to a 3.3 volt, a 1.2, and a 2.5. And I have LED indicators for the 5 volt, 3.3, 1.2, and 2.5. Now I didn't put in transistors here, so that's something I'm going to have to do to drive these LEDs all off of 5 volts. So my current board, the 5.0 and the 3.3 will light up fine, but the 1.2, there's not enough voltage there to drive an LED. So future revision that I'll need to do. In addition to, of course, the FPGA and all the power being supplied to the FPGA, I have an oscillator, and just, the intention is to have a socket so I can put in different speeds and experiment. I do have lots of headers. Basically, every I/O pin on this FPGA, I tried to get out to an I/O header. I think I might have either missed a couple of signals or I duplicated a couple, at least up here. So there's a little bit of cleanup I'll do on the next version around this header specifically. I have some voltage levelers, 2 of them, so that I can have a pair of headers that can run 5 volt type of peripherals. And so it'll level from the 3.3 up to 5, or back down, of course, bidirectional. And then I have 2 spots for 0.5 meg static RAMs, so I can have 1 megabyte of static RAM usable here if I want to experiment with that. And then importantly, I also have an external SPI flash, and that's 128 megabit. And so that flash is where I need to load the programming that this FPGA will load on startup. I have some settings to choose. When I write to it, I have a header here to actually write to the SPI, or potentially to write to the FPGA itself. And I think in the next revision, I might even take out the options to write to the FPGA and only support writing to the SPI. That way there isn't an accidental write or something to that specific FPGA. Probably not a big deal, but I'm going to clean up some of this as I go. There's an indicator down here with an LED that shows when the FPGA finishes its initialization, and it should light up. So you'll see that here on the board that I actually populated, partially populated so far, that there'll be an LED for that. And then again, all these headers just connecting out all of the different IOs coming off this FPGA, which you can see there are a lot of them. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. And they all contain 8 IOs, and then 8 grounds, or actually not 8 grounds, 6 grounds, 2 on the ends, each end, and 2 in the middle. And I'll show those being used in this video. And then this one here, I think I'm just shy a couple of signals, so that's how many different IOs I have to work with as I get on this. And this board, as a reminder, you probably can't read this in the video necessarily, but it is a 4-layer PCB. I've got an inner 3.3 volt plane, an inner ground plane, and then a bottom is what you do see for fill is a 1.2, and the top, what you see for fill, is a 5 volt. So I'll try to get 5 volt to all of this stuff. So pretty simple, not messing with a BGA. I do have on the bottom of all the capacitors that I need, or should have ultimately, for the FPGA. So that's what I've got. And then I ordered up 4 of these specific chips. Again, this is that 144 pin QFP package that I'm using, and I've used one of those on this board so far, and that's what I'm going to actually pull over here and take a look at that. So I'm going to set this all off to the side. Now on the board that I have populated, here's what I've populated so far. I haven't populated everything. I've tried to just populate what I need as I go. And that way, if I do run into major issues, I haven't wasted time and effort or parts on something that isn't going to work. So I've got my power connector, and I'll talk more about that here in just a little bit before I power this up. Again, I got my regulators on there. Now in hindsight, I have 3 different parts, 3 different families of regulators, and in the future, I want to go to the same single regulator part that's probably adjustable. So I would have three of these, or 2 of these actually is what I've done on my more recent design. So I've got 2 regulators on the more recent design that are adjustable, and they'll just have a couple extra components to set them properly, versus having to remember which one goes where. One of them is actually even a different size. I do have the socket in here for this oscillator, and the fastest oscillator I have is a 60 megahertz. So that's what I'm going to use for the time being. And that's, I'm sure, plenty fast for anything I'm going to be doing, but that's what I've got in here right now. With the oscillator, I can run it off of either a 3.3 or a 5 volt. So this jumper is just setting it to a 3.3 volt that's going to go to the oscillator. My jumper selections that configure when I plug in my programmer here, how it's going to program. And I'll come to the programming later here in this video. I've not populated RAM or the level shifters, but I have populated in 2 of these ports. I've just populated pin headers. And then I've taken these little PCBs that I had shown maybe in previous videos, or the design of these in a previous video or post on my YouTube site, that just simply let me have a simple header like this. And then with that simple header, I can populate 8 resistors and 8 LEDs. And there's 2 different styles that I put together. So one is kind of based on how these headers are laid out. So there's 4 LEDs, so 2, 2, and then on the other side 2, 2. So these LEDs pretty much just match the position of the pins, and I can put those on there. Now these are reversible because I have grounds, pair of grounds on each end, and exactly in the middle it's a 7-pin. So I can put these in either way. It really doesn't matter. So I can't mess that up, which is good for me. And then the same thing with this one. The difference with this one is I just have 8 LEDs in a row instead of having the pair like that. And so this is really just routing all those signals into a nice line. And again, this one I can put in either way and it's not going to matter. And I have more of these that I can populate as I want to do more testing. But my goal would be, of course, to get this to the point where I can program it, it loads the program, and I can start testing, writing to I/O or reading I/O. And that's why I populated 2 of these, just to do some of that testing and play with these little boards that I put together. So SPI flash is on board. And a few miscellaneous resistors for pull-ups and things like that you'll see here, and then some capacitors. And speaking of capacitors, on the back side of this, just to get me going, I did not populate all the capacitors on the bottom. I just simply put in, what do I have here? 6 of the larger capacitors I put in, and then I've got a bunch more to fill in as I get time to do that, and I'll do that soon. But I've not had any issues with this yet, but then again, I'm not pushing this very hard yet, so I need to get that done soon. And I'll probably do that before the next video, and I'll populate the rest of the headers, probably try to get the static RAM put in here, and get the rest of the capacitors all filled in so that this is complete. But like I said, I'm incrementally building this out just in case I run into issues. I haven't wasted time, energy, and parts. So if I want to get this up and running, I need to first get power to it. And I've already programmed this flash, and I will go through that whole thing in the tool chain here in just a bit. But I'm going to just start with powering this up. Now for my benchtop power supply, my preference is to use banana plugs for everything. This is just my favorite way to distribute power. And so I'm going to bring power up to my workbench here with that. And then what I put together was just a little distribution power box here that just takes in my banana plugs, It also has outputs of banana plugs, and it has outputs that will use this style of connector from Molex, which I've kind of standardized on for my projects. So I'm going to just simply plug in my banana plugs for now, and I'm going to turn on my bench top, and I'm going to feed this about 5 volts. Okay, so then that just shows me indicator that I got power coming into this. I have a switch that will let me turn on power going out. And that's really handy as I work with this. I can just flip it on, flip it off. I'm not having to reach down to my benchtop power supply. And I'm also putting all the wear and tear on this switch versus on my power, the actual power supply. But then with this, I have a pair of these. So I have really 3 outputs here. And this is wired up so that actually, this is what the little board looks like in here. I haven't shown this before, so just real quick, I'll show this for those that follow my videos in general. I have banana connectors coming in, and then from there, I can take these Molex connectors that I'm using and lock them in. Obviously, solder all of that. I have indicators for power coming in, power coming out, and then of course I got this little display that is showing voltage and current, and that obviously means that all this has to be done in line with the power going out. So that is all part of this, and really that's all this PCB is. So really simple PCB lets me bring in power. I have 3 outputs. I have a spot for a switch that basically turns on and off the power going through this board, and then I have connections for this little display to show voltage and current. And this display, I'm sure you've all seen these products online, Amazon, eBay, or wherever. Voltage is relatively close. Amperage, I noticed, really is pretty poor in measuring amperage. So it's usually off until you actually get up there in current. But this board I'm using here is not going to draw enough current to really matter. And I'm guessing in the video I can kind of see on my monitor here that this will flicker, and that's just a refresh rate and a capture issue. But everything looks solid here as I look at this. So that's the board that's inside of this little chassis with a real quick drill out for these outputs. Maybe someday I'll get a 3D printer and make a nice looking case. But then from this, I need to now plug in power. So what I'm going to do is just grab, I made up a simple little cable that has obviously the male connectors to plug into this. And I'm going to go ahead and plug that in, and I'm just going to set this off to the side for now. And then I can plug this into my board here. And I can now flip the switch and turn this on. And it starts running, and you can see the LEDs. All I'm doing is here I'm just strobing the LED across the 8 of them, and here I'm just simply doing a binary counter from 0 to 255. And so you can kind of see that counting its way up with the highest bit there, and you can see the lowest bit on the lower left. But you'll just see that will populate, or actually maybe that's my highest bit there. But that'll just populate and fill in until it fills all of them, and then it resets back to the 0. And these bottom ones are going pretty fast. But anyways, that's what that should be doing if I've got the VHDL correct for that. And I can slow this down if I want. So an easy way to do that is I could turn this off. I could take out this 60 megahertz oscillator. And I have just a bin of different speed oscillators that I could grab. Like here's a 10 megahertz oscillator that I could put in here real quick. So now I've got a 10 in here, and I'll go ahead and turn it on, and you'll just see that everything runs slower. Because basically the VHDL that I've written for this is all running off of this clock here. And so every time that clock changes, I'm doing something to update or keep track of how long it's been. And once I've hit a certain number of cycles, I then modify the LED output. I'm going to go back to the 60 for now. Okay, so there's my 60 megahertz again and running away. Now to program this, let me set this off to the side here a little bit. I am using this from Lattice. So this is a HW USB N-2B programming cable. So basically it takes USB and has a header, and then it just shows what every pin on that is. And I just taped some of them back, the ones that I'm not going to be using. And then I took their pins out of their header that came with this. Well, actually, they're all independent fly wires. So I took those out of their single pin plastic and put it into this connector here that lays it out in the format that I'm expecting here. Now on my screen, if I look at this real quick, this is my schematic, but the way I've got that programming port right now, it looks like this. So I've got a VCC, well not VCC, a 3.3 volts in pin 1, that'd be the lower left pin here, and then some grounds, and then on the other side of it I have all the SPI signals. So I've got the select, the clock, the in, the out, and then a reset signal. And so then I just grab the appropriate signals from this, put them in the right location here. This connector is, I didn't have a 5x2, I just had a 6x2. So this very end pair isn't even used. There's nothing in there, it's empty. But I can plug this in like that, and that's how I will program this. And maybe I'll flip to a camera that's a little bit further back for a little bit of this. So I've got my power. I can flip this on and off. I have my board here that I can work with, and I have this programmer that I can work with. So maybe with that, I'll flip over to the tool chain I'm using for a second on the PC, and I'll start with the main tool I'm using is this Lattice Ice Cube. So this is, I think, the latest Ice Cube available, but it looks like this is back from December of 2020. And if that isn't the latest, someone, if you know that there's newer, let me know. But I believe that's the latest that I could find on the website. So this is a bit older tool. Or been around for a while, I should say. And maybe these FPGAs have been around a decade or more. I believe it was an acquisition by Lattice of another company. But anyways, that's the version I'm running. And this tool doesn't seem too bad. I would say Lattice's approach to getting the tool and finding what you need is not very good. I'm not impressed with their website. It's hard to find the right things that you're looking for. And then when you do find them, you've got to request licenses and setting up an account. It takes days to get that activated to properly download stuff. So there's probably some streamlining that could be done on Lattice's part when it comes to getting the right tools and making it clear which tools you need. And one of those, as an example, is the documentation for using this tool, this Ice Cube, references a programmer, a separate programming tool that you have to search hard on their website to find it. And it seems like almost everything I would find leads me to contact sales, contact sales, contact sales. And I'd have to go to other people's websites to find the links to find the downloadable files on Lattice's website, which seems really odd, but that's kind of where I'm at. If I look at this tool, though, this is a project that I'm working in, and one of the first things you have to do is you have to come in and add a design file. And I've already done that, and I've added this LED rotate that I put together. And you can either have it open up in the editor, or you can have it open up in an external editor. And right now I have it opening up in an external editor, and maybe I will flip that off for now. And that way I can just come in here and see it. And let's see if I can zoom into this code a bit. So this is my test code that I'm using for the moment. I don't know VHDL very well. I've done some previous projects with it on the ARTI, Digilant ARTI FPGAs or FPGA boards. And I've done some fun stuff there, but it's been a while. So this is all trying to bring this all back as far as remembering how to do this and then figuring out what I don't know and trying to make it better. So you may have lots of feedback on my VHDL code here, but I know it's just something quick and easy for me to test a couple of these ports. Now, the way I've got this set up is I'm going to jump to one other file real quick. I put together a constraint file board file. So basically, this is configuring how my board is going to be, seen or usable from my other code, for example. So I have an input called I_clock, and I'm saying that's on pin 20, which is on the left side of this FPGA. And maybe I can go back into that. So on the left side of this, it connects over to the oscillator through a small resistor, but that'd be pin 20 that I'm bringing in. And then I created another, basically a name of a wire called O_LEDs or LEDS. And you can see here that there's 8 of those. So when I see this name, it's really these 8 signals from this FPGA, and they're on pins 95, and you can see which ones I've called out up through 104. And those would be on the right bank over here. And then I did the same here for, I called it LEDS2. So LEDs 2, and again, I've got 8 I/O pins, and these are the pin numbers that correspond to how I'm going to refer to it. Now, the reason I didn't give each its own individual special name, and I did it this way, is because I'm going to write 8 bits at a time to OLEDs or OLEDs2 and not have to address it pin by pin. But that file's there, and if I go back to my code then, basically this is just going to do some counting. And in this case, I'm saying, well, I want you to count up to this number here. What do I have? 2.5 million. So when you get to 2.5 million down here, I just say, if you reach that, then do something. And what I do is I add 1. I add, the value 1 to this wire WLEDS. And so that basically is an 8-bit. It adds 1 to it. And then I go to this other signal WLEDS2 that I set up. I start with the value of 1. But then I just simply check what's the value of it, and then I'm manually moving that bit is essentially what I'm doing with this case statement. So every time it gets to this many cycles, it processes this chunk of code here. Now this code doesn't seem like that I should need to do it that way. I was thinking I should be able to do something like this, where I just grab 7 of the bits. Basically, this is shifting left by 1. But this, for some reason, is not working for me. So I'll have to dig into that. And I'm sure it's just me being a novice at VHDL, and there's something here that I'm not understanding why that wouldn't work. But what I do then is I just say, well, what is the current value of this LEDS2? And then depending on which one it is, I just move the bit accordingly. And then I actually send those values out to OLEDs or OLEDs2. And that again goes back then to this, which is, there's my OLEDs and OLEDs2. So that's how it knows which bits go to which pins. So that's the code I've got. Now, when I've got the code in here, if I want to actually get this onto my board, what I need to do is put in the code, which I've got, and then I can double click this run simplify prosynthesis. And that down here in the lower left says it's running, and then I should get some output here in a second that just shows me what did it go through and do. And this came through. I don't see any errors. Synthesis succeeded. So at least is happy with or not upset with the VHDL that I had in that example. But then I have to come down to this place and route is maybe what the PNR is. And I can double click here to choose which implementation is going to be used. And that goes up to the code I had above. And then I can come down to make sure I've got my constraint file, which I showed before. And I can then run the place and route. And so it's running the placer right now, and you can see it's flipping through a bunch of stuff. It'll then move on to some other steps. And at the end of it, it should generate, I think it's called a bitmap file. And so that bitmap file is what I'm going to need to put onto my flash down here. Okay, so now it's running a packager, running a router. And I am by no means very up to speed on all the FPGA build out process here, but just kind of starting to get used to running or working with this tool, I guess. Okay, at the end, then it says that this bitmap succeeded, and I can see, where, if there were any details in here that were of a concern for me. But what I'm really looking for is that succeeded. And it did. So from there, then I might go back and say, okay, I want to now program that onto my board here. I'm going to flip over to a different tool, and this is a Diamond Programmer. This is one that you might have to dig a little bit to find it on their website. Do get the latest version. If I go to About, this is the version I'm running right now, 3.13.0562. And basically in this tool, you come in here and you configure the device. And so I'm telling it that I'm going to use SPI serial flash. And the specific flash that I chose here, right here, is a WinBond. And it's this W25Q128JV. Now, initially, I had a hard time finding this software at all, and the links I could find was to a slightly older version, and it didn't have this exact SPI serial flash, or it listed it in a section like a beta drop-down, and it didn't work. I had to pick a different vendor's SPI flash, and it ended up working. But then later, after digging some more, I found this version, a little bit newer version of the Diamond Programmer, and it does support, without it saying beta on it, it does support this WinBond SPI flash that I'm using. So I'm going to tell it I want to do SPI flash programming. I can then choose where the file is, or that'll get also chosen up here in this line up here. I'm going to choose my SPI flash, and I'm good with all that then. And then over here to the right, I can do things like detect cable. So if this programmer is plugged into my USB and the drivers are loaded fine, which I had no issues with, I can just simply say detect cable, should find it, and I'm going to use the default settings basically that go with that. So then what I need to do is make sure that my board is off. They say that when you plug this programmer in, make sure the board is off, so I can see it's off. There's no power LEDs. I got the switch off, and I'm not outputting anything here. I'm going to connect up this programming header like so. And again, I'm just simply sending the right SPI signals, SPI clock, etc. to where it needs to be on that. And then I'm going to go ahead and actually turn this on. And so I can see I got power there. The little programmer shows I've got USB power and I've got board power. Both of those have to be lit up. And then on my screen here, I just simply say under design that I want to program. And it maybe takes just a few seconds here to do something in prep, but then you're going to see this program light will start flashing once it starts interacting with it. And so I can see it's initializing, enabling, erasing, disabling, enabling, programming, etc., verifying, finalizing, and that all completed. So at that point, I have taken this program, which is the same one I had on there before, but I've taken it and I've written it to the SPI flash there. So then I can turn this off, I can get rid of the programmer, set that aside, and now when I turn my system on or turn this board on, it's going to run that code that when it turns on, it pulls from flash and starts executing. So that is where I'm at with this. The tool set, the iCE40 2 seems to be perfectly fine, seems to get the job done here. There is another tool that I was playing around with, this iCE Studio, and really wasn't liking that one at all. So I'm probably going to stick with this Lattice iCE40 2, and maybe as time permits, I'll go back and play with iCE Studio. iStudio seems to be, and this is me not knowing it, but I could not find a way to just support the FPGA directly. You had to pick a specific board. And of course, my board isn't going to be in that list of supported boards. And to get the board supported, you had to go out to a different tool and get that tool to support it before you could use it inside of iStudio. It wasn't easy. I was a little bit surprised that I couldn't just create a project based on a specific FPGA, and instead I was limited to just choosing dev boards that are out there and popular. But I'll continue to play with that in the future. But right now, my energy is going to be in IceCube 2, which I don't know. I've used some of the Xilinx stuff in the past. That's what I did my RD7 stuff in. And the IceCube just kind of feels like a lighter weight version of some of that, and felt okay, I guess, as I went through it. Nothing felt like it completely didn't make sense or wasn't something I could work out by looking at the documentation. Whereas with the iStudio, that looks quite foreign and really doesn't seem to be able to support just an FPGA without a specific supported board, which, like I said, mine would not be supported. So I have a lot to learn on the VHDL, or if I get into Verilog, or if Lattice IceCube 2 supports System Verilog. From what I'm seeing, my guess is it doesn't, but I could be wrong. That just is something maybe I don't know enough about yet. But like I said, I think next steps are for me to go ahead and get in the rest of the components here, rest of the headers, to get these LEDs populated, get the RAM populated, and then maybe see if I can do something with that RAM. I think when I get to VGA, I am going to try to get a VGA signal coming out of this. I think I can just use one of these headers. And I might need a pair of headers, actually. So it could be that I just pull all the signals I need off of a pair of headers. So I might make maybe just a little quick custom PCB that plugs into a pair of headers. I probably didn't do the spacing super consistent, so that might be a challenge. So I'll have to figure out how I want to do that. But I'll have to connect into probably 2 headers to get all my signals. And maybe not. Maybe I can do it on 1, but more to come on that. I'll see if I can't get something driving a VGA signal and see if I can't use the static RAM to basically use as VRAM for that VGA output. And all I'd be doing is some sort of a test pattern or test text to get started. I have a lot to learn on VHDL and FPGAs, but this seems like a good step 1 for me as I get going. Maybe if I flip back before I end this video just to my EasyEDA Pro that I'm using, if I go over to my projects, I do have 2 other boards pretty close to ready to go. And so one of them, and I've had videos on this recently, so you can take a look at this, but I have, let me see if I can get it pulled up. It's pulling up on my other screen here. But I do have this board. And so this board, I need to probably make some changes to it based on what I'm learning on the one I'm putting together right now. But this is a BGA version instead. Let me maybe just go to the 3D view for simplicity. But much of the same thing. So it's just, can I do a BGA type of setup? I move the power to the top, and instead of these LDO regulators, I've got an improved way of doing that that I've talked through in other videos, so I won't spend time on that now. But really then, instead of using all these other headers, I'm going out to a connector that could go to a separate board with whatever type of headers or other functionality on it, static memory, dynamic DRAM, whatever it might be. And then I had also created a slightly different version of this that, instead of this fancier setup, uses LDOs. And let me see if again, it's going to my other screen. But just opening up the 3D of this other version where I have a couple of LDO regulators instead, and still is a much better design, I think, than the current board, this QFN version that I'm using. But this BGA version, pretty decent power setup, I think, and that would be the next one that I'm going to work with. I do have some changes though based on things I'm learning on this board here. I forgot to put in resistors related to SPI, so I don't have any inline or the main thing would be inline resistors for some of the SPI signals. So I'll probably add that to what you see on the computer screen to that board before I order it. I'll probably put in transistors for driving all of the different status LEDs. So there's this C-done, the 3.3 volt, 1.2 volt, and 2.5 volt. All of those I'd like to have driven off basically a 5 volt signal so that I can just use for example, the 1.2 volt to turn on that transistor to power and run the LED. I think that's hopefully that makes sense, and what I'm thinking hopefully will work there. But so I might add 4 small little transistors to all of these boards to help drive those LEDs. And I'm sure even on these output ports, the same could be said, that maybe instead of trying to drive these LEDs directly, which in the documentation they really seem to say this FPGA is really not meant to be doing that. But I think it's because these LEDs take such a small amount of power. And you'll even notice over here, this is showing 0 amps, but if I look at my benchtop, it's showing 0.05 amps is how much I'm totally drawing at this point. Seems like this little guy doesn't register until I get up there a little bit higher, whatever its minimum threshold is to start registering that correctly. But if you got any questions on this, any thoughts, things that you think I should pay attention to as I step forward, do let me know. But I'm going to say this board, in my eyes, has been a success so far because it's actually working. So sometimes I surprise myself or get lucky on some of these designs when I put them together. But more to come. So I think the next update might be this built out a little bit more or all the way. Maybe I can do something a little bit fancier other than just simply control some LEDs. And then I'll get 1 or 2 of these other PCBs in that go with the BGA, the smaller BGA. And that is a 121 ball BGA. Goal after that, though, is they have a 256 pin BGA that is in this HX8K. So that would be my ultimate goal, because that would give me a ton of I/O that I could do something with. But I am a few steps from that, and likely a couple of months from that. But again, I'm happy with this, and we'll see how things proceed. And drop a note if you got feedback, questions, suggestions, whatever it might be. Thanks.